Greetings, I'm Mark and I love coding. Now today I'm going to be working with the processing language, which is a Java language, a little higher level, which I'm going to show you how I solved the problem when I first started coding years and years ago, and it dealt with writing apps more or less, which back then we called programs, that were working with varying speeds of CPUs. And when you have certain forms of animation, even on a website, rotations, whatever, can be affected by how fast the processor is on a system. And how fast the processor isn't always about the processor itself. A lot of times it's about what might be running in the background as well. And so I would write these little test apps that went into the code for when it first started. It will create some kind of result. That result I can use in the code to whatever, to say, okay, this is a slow processor, we need to make this animation run faster, or vice versa. I use a for loop in which to do that. If you're familiar with for loops, it should be pretty easy for you. If you're not, it is also easy as well. This little app, including the telemetry that I want to create with it, just so you can see the results while we do it. This little app is only roughly about 32 lines, give or take. Okay, and so let's get started. Now over here on my screen, I have something that I create to help me start all my apps, because they all kind of basically need the same thing. When you start processing a new sketch, it is a blank editing window. And so I created this with some essential things, and one of the things that I like in my apps when I write them. And one of the first things you're always going to need is the setup function, which the function is indicated by the opening squiggly brackets and the closing squiggly brackets. And then the draw function, again, opening and closing squiggly brackets, curly braces, whatever you want to call them. What happens usually in setup is initialization of variables. Above setup, you would declare global variables. And in draw is a loop that continually goes on. Now, I might repeat myself in other videos. So when I first load this, because I've already got a name of it, calling processing startup here, I'm going to save it as a new file. Save as, and what I'm going to call this is CPU, and we're going to test. CPU test. All right. Okay, you're going to have to also forgive me. Although I've been coding for a lot of years and also a lot of years not coding, I still only type with 2 fingers, so bear with me. Okay, so here we go. Now when I go into this, because of the fact that we want the telemetry windows going up, I'm going to create a Boolean, a start Boolean, something that says when I do an action, in this case it's going to be tap or click on the screen, it will start the test, and when it's done, you're going to be able to tap the screen again and quit the app. So let's get started here. Okay, we want to use a Boolean variable. A Boolean variable is always resolved to true or false, and this one we're going to call just start, and I'm going to actually initialize it as well to false because we haven't started yet. Okay, the next variable I want is I want to call it my test variable. This is about the actual for loop. When it completes the actual test, which this for loop takes place in one frame. So if you're familiar with processing, what it does is in that draw loop here, it's going to try to loop through this at 60 times a second, 60 loops a second. But what happens when you put something like a for loop in there, or multiple for loops, or nested for loops? It does kind of delay how fast that can actually get through at 60 times. It might slow down to even 30 times, depending upon how much you got going on in that draw loop. And so what we're going to create here is a for loop. It's going to happen one time, give you a test result. And so to do that, I'm going to create another Boolean, and I'm going to call it test. Okay. And you know, that works out fairly easy for variables. That's pretty much all we're going to need for this. And in the end, if you're putting this in an app, you won't need any of these variables at all. One more variable, or actually two more variables. What we need is a variable to hold this. The loop is based on a certain number that we put through the loop, which we're going to experiment with here. I have my idea number, but you might have yours. But basically, what this app is going to do is it's going to check the milliseconds currently by reading the milliseconds off the machine, off the device. It's going to store it in a start millisecond variable, and then it's going to check how many milliseconds went by when the loop is done. And to do that, we're going to need an integer, and I'm going to call that START mils for milliseconds. And then I'm going to have a result variable, because we're going to need to get the result. And this is a number that we're after. Now, you can make this number with addition, multiplication, whatever, anything you want after you get it. So you can work it in to whatever motions or whatever you're trying to control the speed of based on processor speed. Okay, so let's get further on into this. Now, we do have our surface. I did tell you about this, or what this basically does for me is when I start my app, surface.setLocation basically will put your processing window wherever you want it. For me, I like to put it up in the upper left-hand corner, which is what these calculations are all about. And it's based on the actual display width itself. So we're going to work with the size. Now, I have a 4K display, so my sizes can be very interesting when I like on a 1080p display, whatever number I type in is going to be twice as big. So you might consider, if you have a 1080p display, to divide what I put in by half, so it is reasonable for you. All right, so I'm going to call size right here. This is a function that sets the screen size. The first number, which I'm going to say 800, is the screen width, or the sketch window width, and the second number, which I'm going to say is 400, is the sketch window height, and again, semicolon. Now, because of the telemetry I'm writing, which I'm going to use the text function, I want to set that up right now. I want just to make it real simple, derive from the center, and then base the size, which in playing with this, I kind of came up with the size based on the width of the sketch window, or the device, whatever you're putting it on. So first up I want to do is I'm going to do a text align. Now this function allows you to tell where those letters are deriving from when you first print it. Its default is the upper left-hand corner, more or less, of where you actually tell it to start with right from your location that you place in the text function. And so we're going to say text align, and I want it to be center, which you have to do all capital letters. Center. And again, if you have any problems or have thoughts, don't understand something that I am saying, right up here on your top bar, it might be hard for you to see because of how small things are, is a help. And in there, there's a reference guide, and you can click on that and find all the functions that processing can do, or basic functions, and some go even further in depth, and so you have to look a little bit deeper to find some of those. And later videos I'm going to show you some things that I found difficult. But for now, let us continue. Now I'm basically aligning the text to the center, so I can derive it all from the center when I tell it where I want my text to go. And I'm going to do the text size, which again I was saying I based this off the width of the sketch window, which is 800, and I'm going to divide that by let's divide that. Let's see what happens. We're just going to experiment. Divide it by 10. No, let's divide it by 20. All right, I'm pretty much done setting this up. We're going to get into the code now. It's going to go pretty quick. First thing we want to do in here is, because this is a loop, when you're working with the draw function, unless there's some reason, which there are reasons, that you don't want to, it's like the draw loop is basically like the roll of film moving. It runs by at 60 frames a second, and each time you want a new frame, because there might be some motion or something happening, it needs to be wiped out to write the new one. And to do that, you set up a background color, and it will always, in the draw function, come back to this at the top of the draw function and create that color. And so in this particular sketch that we're working on, I'm going to make it black. So we're going to go background. And when you're working with color, oops, typo. When you're working with color, whether you're using background function, fill function, or stroke function, the default is an alpha value, RGB, red, green, blue. Each one has a value between 0 and 255. You can change that, but the default for processing 3 is RGB values between 0 and 255, 0 being the darkest. So if you were to, for instance, create 255, which is red, that's the highest you can go with red. And if you said 0, 0, that would create a red background. And I will show you what that looks like, because we can run this at this point in time. Red. Again, you can take that all the way down. Say, I want it just dark red. It's just 50. Again, now it's a deeper, darker red. But in our case, I want to use just black. Now I can turn this to 0 and get the same result as black, but you can also, if you're working in grayscale, just use a 0. Single digit, it's black, as you can see. All right. The next thing I'm going to do is, because I'm going to be working with the telemetry, which is basically some text on the screen telling us what to do and our results. I want to change those letters to white, or in the grayscale of between black and white. And to do that, any text, you need the fill function. And I'm going to say 200 because I don't want it bright white. So make it a little more on the gray side. Then, first thing when this app starts, interesting. We want to test. We want to do a test. We want to say, here we go. If test, which we can say, in this case, we can say equals true, but it is absolutely the same to just say if test, and it recognizes it as a Boolean, and it's saying, oh, if test, that means is it true? Then we want you to do everything between these brackets here, these curly braces. After that, what you want to do is run the test. Well, what I want to do here before I run this test actually is I want to create another function. And this function is a built-in function to processing, and it's about mouse press. Now, if you are familiar with processing for Android, mouse press is synonymous with the touch or tapping on your screen. Same thing. You can use mouse press and get the same result in Android. On the other hand, you cannot use touch in Java Android, or rather Java processing. So what I'm going to do is create this function. Like I said, it's a built-in function called mouse press. Pressed. And what happens is if it detects the mouse press, anytime you're in your draw function, if it detects the mouse press, it's going to run whatever you put in this function that we're creating right now. And so what I'm going to do here is create a little if function. And this function is basically designed to start the test, or say after you end the test, if you want to just touch the screen again or click on the screen, it ends the test. So, excuse me, I got a little frog in my throat. So here we go. Let's create a little if statement. If, and we're going to say not start, and we're going to use and. Two ampersands together is and. So basically it's going to test these two results, and both these results, because of the ampersands, the and ampersands, have to resolve as true for this if statement to continue on here. Now I'm going to show you also in this if statement a little trick that I've learned, a couple of little tricks here. First off, we're going to say basically this is the first click. It's going to start. It's going to tell us that we've started it, the test, and as well that we have clicked it indeed. For some reason, well, no reason. We're just going to continue on here. Let's go. Okay. S-T-A-R-T, here's one of the tricks, equals test, which equals true. And so that's basically saying that yes, I've started the test, and I've told that now that I've started the test, I've also told it to begin the test. And now you can, in this case, you can't put an else statement in here, because what I wanted to do is, if you touch the screen and both of these are true, I want it to exit the app, basically. So I can't put an else statement, but I also found that when you're inside a function such as this and there's not much more to it, that you can use return. And it completely kicks you out of there and sends you back. This will work. In fact, let's I think we can test that right now just to see. Click it, start it, end it. Okay, let's continue now. I recommend also, which I should do more often, is to save as often as you can. And in this case, I use, you can go up in the menu and hit save, but I also as well use Control S more than that. Let me open up this screen a little bit more. And so this is where we're at. We're in the draw function. Now we're checking the test out. Now, if it's been told to do this test, we're going to start our little loop here, a little for loop. And let's begin. We're going to say for set up an integer. Now, if you're familiar with any kind of coding, most languages have for loops, and if you're familiar with like for loops, functions, so on and so forth, whatever is defined using integer or float or Boolean or whatever within a function, a class, for loop, and if statement, if it's defined within there, it is a part of that and remains in there. And so anything like this I could be defined someplace else, but only the I within this for loop is part of this for loop, will work with this for loop. And it won't affect any other I's anywhere else that might have been defined within your application or program that you're creating. Okay, so we want to start this at 0. Because we're just doing a basic count, and we want to say as long as I is less than a number. Now this is how many times we want it to loop. Now you might be surprised at how many loops this can do. I mean, it will do as many as you want, but you might be surprised at how quickly it can do. Now, in experimenting with this over the years, I've learned you got to have this a pretty high number, and it's actually a lot higher these days than it was. I found for me, let's just try 2.5 million. Crazy, but that's the way it is. Now we increment the I, and then so this is basically saying that while I is less than 2.5 million, let's just 2.5 million, just keep doing this loop. Now in here I'm going to do one calculation. It's not much. and I'm going to say our results are equal to milliseconds minus start milliseconds. Now you're wondering, wait, where did it get that from? Well, what I should have done before the loop started is actually set my start milliseconds equal to milliseconds. And so what that does is it sets this equal to the current milliseconds just before the for loop starts. And what I do in the for loop is just basically send the results continuously. Now I could do this afterwards too, but I felt having some form of a calculation in there in the moment, you know, just a little bit of something more than just the loop. Slows it down just a little bit, and you actually can see the difference. And so in the end here, when it's done, when it comes out of the loop after it's done 2.5 million times, you're thinking, wow, that's going to take a long time. Wait. I'm going to tell it that the test is over. So I'm going to say test equals false. Now you can see here, because we're testing to see if it's true or not. Now that's basically it. I can take the end result, because whatever the last time when this ends, whatever result ends up to be is the result we're looking for. This is it. This is basically the whole thing. And honestly, you don't even need to have the if statement for test, and because if you're putting it within an app, all you need is to do this quick loop, give it your results, and then continue on and use the results to how you want to use them. So it's pretty basic on that level. Now what I'm going to do here is the next thing, which is the telemetry. We need to actually see some data here, because if you're just putting this in code, you can use the data in the rest of your code, but since we don't have any more code than what we're writing, we want to see the telemetry. And it's kind of interesting when you plug in different devices in Android mode and see actually how fast these things can get done. And so here we go with our telemetry mode. So we want to say if backspace started. Now in here, oh wait, not started, start. What's going on here in this whole our little loop area that we're doing here, what's going on is that it's first seeing if test is true. If it's not, it goes past here. If a test start is true, then it puts up these results here. But if it's not true, it skips and goes on. We're going to put an else statement here in a moment. But first off, we want to say, okay, yes, this is true. So this did this loop. Test is true. As you remember in our little mouse press here, it sets all these to true, start and test. It comes into test, does our loop, comes out of that, sees that start's done, and it creates our telemetry on the screen. And so we're going to create a temporary variable, and this is within the if statement, so you cannot use it out of this if statement. And so, which is interesting to me when you're defining a string variable, you have to start it with string just like an integer, int, float, float. But string is the only one, for some reason, of the few. There is a few more, but string is one of the ones that you capitalize first. Okay, I don't understand it, but I do it. Okay, and I'm going to just say res for results. So that's going to be a string. Now I'm going to use this little function here. This for me just made the numbers a little more readable to say. So I'm going to convert the actual floating decimal point that we got going on in this to a string. So we're going to use the number format, which is NFS in this case. And you can look that up also in the reference, and there's a few other ones that you can use. And I'm going to use results, which is the results of the number from our test. And then I'm going to multiply that because it's in milliseconds, and what I'm trying to do is convert it to seconds, just to get an idea. And so our seconds are going to be 0.001. And after that, when you're using this NFS format setup, what you get to do is you can say on the left side of the decimal point, I want so many zero paddings. In this case, we don't want any zero paddings. So if there is a non-zero number, it will put it there. But say if I put 3 zero paddings and there's only one number, like number 1, it will put 2 zeros in front of it. In this case, we don't want any zero paddings, so I am going to say 0. And then on the right side of decimal place, we want to know how many digits we're going to go back that way. And in this case, it's a little above what we really need. We can say 4 just for the heck of it. So, and we're going to be done with that. Now, next thing, we want to print out that telemetry, and I'm going to use the text function. It's built in with processing, and I'm going to say that your system, let's say it's scored, and we're going to say this is the number that it's scored. And we're going to put another little variable in there called results. The text file, if you want words on the screen when you're using text, you need them to be in the quote marks, double quotes. Then you can add your variable with the plus sign, which is going to have our results. It's a basic integer. Then I'm going to say plus, but this I'm going to use here particularly makes it easier. This little slash here is an escape code, and when you put the N, it puts in a, like you hit return and go to the next line. And so we're going to go to the next line, and we're going to add on top of on the next line, we're going to add our results, which have been turned into a text and configured to the way we want them to look. Okay, and then I'm going to just say that it's whatever that result is. Oops, let's go back. I like to put these spaces in here, make it look a little cleaner. And we're going to say seconds, because that's what we're trying to calculate in that. And then what I want to do is drop down another line, and then drop down another line, and tell you to tap to QUIT, tap to quit. Okay, so what we got going on is going to print this, the score results from your loop. It's going to drop down a line. It's going to print out our reformatting of the code in a string file, and then it's going to print out seconds, drop down 2 lines, type, tap, continue. Now, where in when you're using the text function and a few others as well, within it, you need to tell processing where on the screen you want it. And in this case, what I just want to put it in the dead center of the screen. And because we use the center function, it will actually start from the dead center of the screen and spread out in both directions. And so I'm going to say dead center is width divided by 2, comma, HEIGHT divided by 2 as well. And that is the end of that. And so what we got here is our telemetry completed. Now, say this start function is happening. Test is still false, because remember, once you start this, it's going to keep looping in here until something tells it what to do. Test is false, it's not going to go in here. Start is false, it's not going to print out telemetry. So what are we going to do? Well, we're going to put an else in here, and another text function, and we're going to just say, let people know, tap the, or let's say tap to start. Yeah, tap to S-T-A-R-T, tap to start. And then what we want to do is tell it again the center of the screen. And what I'm going to just do to make it quick is I'm going to Control copy, Control C copies, and then I'm going to Control V paste. And some people are against copy paste because it can make you forget things or copy paste wrong things, but you know, processing will let you know if you messed up. That's for sure. Okay, I would say that's pretty much it. Let's save this, Control save, and run it and see what happens. Here we go. Okay, there it is. Now, I want that all to be bigger. And so to make it bigger, because it's based on the width of the screen, or our little window here, and I did it over here, bigger, smaller number. Now again, this is based on, the width here is based on the width of your sketch window. Okay, so here we're going to save this again and run it. Is it bigger? Oh, I like that better, but let's go a little bit bigger. Let's just say 10 just for the heck of it. Let's see how big that is. That's pretty big. I wonder what our results are going to look like. Well, let's just try it. Now we can go over here and click or tap on it. If you've got a touch screen, it works pretty good. Tap on it. Up. Too big. We have an error as well. So let's go back here to, let's say 13 and run it. It's a little bit smaller. Tap it. There should not be zeros. It should not be zeros. So we do actually have an error. Because I don't see any errors actually in any of it. Except for, let's just change this number. Let's see what happens. To 5 million. And run it. Tap. This processor in this PC was so fast that actually did 5 million loops. 5 million, you can see right here, 5 million loops with a small calculation in the loop in 16 milliseconds, which is 0.016 seconds. Crazy. Okay, so the next thing we want to do, we see a result here. This is a pretty fast CPU, but the truth be known, it definitely isn't the fastest, that's for sure. And the results being as such is pretty interesting. Run it again, tap. So it did it in 15 milliseconds. Run it again, tap 16. So you kind of get an idea where this is going, and we can expand on that time from 5 million to say 10 million. Let's just do that real quick. Or let's say, because it's easier, to 15 million. Let's run that and see how long it takes. Tap. It's instantaneous. Clearly took about twice as long to do this little loop of 15 million calculations, which is basically this start milliseconds minus the current milliseconds in 31 milliseconds, or 0.031 seconds. Now play with this and try it on your PC or your friends or whatever. You can get an idea how fast things are going, and you can also try things like running things in the background to see how much this might change. To do Android device, there isn't a whole lot to it. First off, you want to save what you've been doing, Control Save or Control S. Then over here on this side of your little editing window, little tab that's got the Java there, you click on it. Now if you've already turned on Android or downloaded Android mode, you can just click on it. But if you haven't, you can go here to add mode, and then it's pretty obvious at that point in time as to what you can add to this. Not just P5.js, Python mode, all these extra little deals. I've never seen the shader mode. I might check that out one day. All right, so since we've already got it selected, we're just going to convert it over to Android mode. And we first off see our first little error, which is it doesn't like this set location thing. And so what we're going to do is comment it out. Now, in general, the size thing will work, but you just want it to fill your whole device. I found that you can type the word, the command, the function command, full screen, full screen, but interestingly enough, without it, it will still do full screen. And so here, let's save what we're doing. We're going to just first off run an emulator. And there it is, the emulator. Now we can tap our screen to start. Now it's remembering. We've tapped it, but the emulator is running 15 million calculations right now, or trying to, and that's going to take a little time. And so what I found is the difference between the Android and the processing power of a PC is, well, there is a vast difference. And this sure is taking its time. I'm going to stop it. You can hit your stop button, stop it. I'm going to change this number. What I found worked for me earlier on, and it still is a little slow in the emulator, is 2.5 million. It's 2,500,000. Control save it, and we're going to use Control Shift R and run it, same as running emulator up on the menu bar. And start it up. Now let's see how quickly it does it. There it is. There's our results. And so basically, it says that it took 19.186 seconds to do those 2.5 million calculations. Now I'm going to plug in here this is a Samsung Galaxy S21, and we're going to run that same on the Galaxy Samsung S21, and just over here click play, and as you'll see, it'll load it up, and again we can touch it, instant results. It did those same 2.5 million calculations in 138 milliseconds, or 0.138 seconds. Tap to exit. All right, that's kind of interesting. We're going to do another device real quick here. This time I'm going to do a 8-inch Samsung Galaxy Tab. It's got Android 11 on it. Let me put my passcode in it. And now we're going to start that up again. And it's sending it to the tablet now. And as you can see, let me see, is it going to flip for us? Yes, there it is. Let's tap it. Our results. It did it in 643 milliseconds. 0.643 seconds. Considerably slower than the Samsung Galaxy S21. I hope you can get a little bit out of this. What I'm going to do here, just in case I forget to put this up on GitHub, a link to it down below. What I'm going to do is give you a full screen right here. Roll it up to the top. Now I recommend you pause your video, write down this code. Now I'm going to scroll down for you. And then pause your video, write down the rest of the code. I hope this was at very least fun and you get some use out of it. Thank you for watching. I'm Mark, and I love coding.